Hi, my name is TTJ Kepsi Richard. Welcome to my YouTube channel. Please consider subscribing to my YouTube channel. This will make my YouTube channel grow and I can share more mathematical content with you. Please like my video, share and comment because your comment keeps me going. Today our discussion will be on binary operation. Before the video ends, I'll take you through what binary operations are. Then we'll solve some problems on a set defined on a particular binary operation. We'll also learn how to find an identity element of a particular binary operation, as well as the inverse element that exists on a particular binary operation. This will be a very interesting engagement, so please come along. So we're going to talk of binary operation. Binary operation is an operation having members of a set defined on it by the combination of two members of that set. And the set most at time in contention is a set of real numbers. And the operation that we commonly use include star, delta, this delta turn outside down, people refer to it as nabla, as well as this, and any other operation. So now, when a binary operation is defined on a particular set of real numbers, and we are asked to evaluate a member of real numbers by the two members of that set of real numbers, how do we solve that? So let's look at our first problem where a binary operation is defined on a particular set of real numbers. So the question says that a binary operation delta is defined on a set R of real numbers by x delta y equal to x plus y minus 2xy, where x and y are members of real numbers. We should evaluate 4 delta 2 and 2 delta 4. So how do we solve that? So remember we said x delta y is equal to x plus y minus 2xy. Then, if you are asked to find 4 delta 2, it simply means that any place we see x, we substitute the 4. Any place we see y, we substitute the 2. So this will be equal to 4 plus 2 minus 2 times 4 times 2. What do we have? 4 plus 2 is 6. 2 times 4 is 8 times 2. That will be 16. So minus 16. 6 minus 16 is negative 10. Then we can say 4 delta 2 is equal to negative 10. So now the second one that we should find 2 delta 4. Remember x delta y is equal to x plus y minus 2xy. And we can say 2 delta 4. Any place we see x, we substitute 2. And the y substitute 4. This will be equal to 2 plus 4 minus 2 times 2 times 4. 2 plus 4 is 6. 2 times 2 is 4 times 4 will be 16. 6 minus 16 is negative 10. Then we can say our 2 delta 4 is also equal to negative 10. So let's look at our second question, which is that binary operation star is defined on a set R of real numbers as A star B equal to A plus B plus half AB. We should find 2 in bracket 2 star 3 bracket close star 4 and C star bracket open 2 star 5. So how do we solve that? In solving this, you need to deal with what is in the bracket first. Then you can operate it with what is not in a bracket. So remember, A star B is equal to A plus B plus half AB. So we can say our 2 star 3 star 4. So we can find 2 star 3. 2 star 3, it means A is equal to 2 and B is the 3. So any place we see A, we substitute 2. Any place we see B, we substitute 3. Then we can say 2 star 3 will be 2 plus 3 plus half 2 times 3 in brackets star 4. So how do we solve this? 2 plus 3 is 5. Half times 2 is 1. 1 times 3 will be 3. You can have 5 plus 3 star 4. 5 plus 3 is 8. So you can have 8 star 4. So the 8 star 4 simply means that any place we see A now, we substitute the 8. Any place we see B, we substitute 4. So our 8 star 4 will be equal to 8 plus 4 plus half 8 times 4. 8 plus 4 is 12. Half times 8 is 4. 4 times 4, that will be 16. 12 plus 16 will be 28. Then we can say A star B, we can say 2 star 3 star 4 is equal to 28. So the second one says we should evaluate 6 star 2 star 5 in bracket. So remember to deal with what is in the bracket first. Remember that our A star B is equal to A plus B plus half AB. Then we can say 6 star. Now we deal what is in the bracket. That means any place we see A, we substitute 2. Any place we see B, we substitute 5. So we can have 6 star bracket open 2 plus 5 plus half 2 times 5. You can have 6 star 2 plus 5 is 7. Half times 2 is 1. 1 times 5 is still 5. So have 6 star 12. Now 6 star 12, it means that any place we see A now, we substitute the C. And the 6 and the B, we substitute 12. So 6 star 12 will be 6 plus 12 plus half 6 times 12. 6 plus 12, that will be 18 plus half of 12 is 6 times 6, that will be 36. 18 plus 36, that will be 54. Then we can say 6 star 2 star 5 is equal to 54. So our next question says that a binary operation nabla is defined in a set R of real numbers by A nabla B equal to A over B minus B over A, where A and B are members of real numbers and A and B are not equal to 0. This implies that when A is equal to 0 or B is equal to 0, it will make the operation undefined. We should evaluate 3 root 2 minus 2 root 3 operation root 3 minus root 2. Then hence, we should deduce the value of root 3 minus root 2 operation 3 root 2 minus 2 root 3. So how do we solve that? Remember, we have A nabla B equal to A over B minus B over A. So if we have 3 root 2 minus 2 root 3 operation root 3 minus root 2, it will be equal to, so any place we see A, we substitute this. Any place we see B, we substitute that. So it will be equal to 3 root 2 minus 2 root 3 for the A over B, which is root 3 minus root 2, then minus now B over A. So this is the B, root 3 minus root 2, then over the A, which is 3 root 2 minus 2 root 3. So now how do we solve this? How do we evaluate this? This becomes said, we need to what? Conjugate. So we find the conjugate set. The conjugate set of this denominator is root 3 plus root 2. We multiply both the numerator and the denominator by the conjugate. The same way, the conjugate of this is just the addition, changing this sign to addition. Then we conjugate both the numerator and the denominator by that. So in a nutshell, we'll have 3 root 2 minus 2 root 3 in bracket times root 3 plus root 2. That's the conjugate set of this. Over root 3 minus root 2 times its conjugate, root 3 plus root 2. Then minus the same thing. We multiply both the numerator and the denominator by the conjugate of this. You have root 3 minus root 2 times 3 root 2 plus 2 root 3 all over 3 root 2 minus 2 root 3 times its conjugate, which is 3 root 2 plus 2 root 3. So now we solve this. So 3 root 2 times root 3 will be 3 root 6. 3 root 2 times root 2 will be 3 root 2 square. And this times this 2 root 3 times root 3 will be 2 root 3 square. Then 2 root 3 times root 2 will be minus 2 root 6 for the top of this. Over now 3 root 3 times root 3 times root 3 will be root 3 square. Root 3 times root 2 will be plus root 6. Root 2 times root 3 will be minus root 6. Then minus root 2 times root 2 will be plus, minus root 2 all square. That's for this side. Now let's deal with this side also. So minus. Now root 3 times 3 root 2. That will be 3 root 6. Root 3 times 2 root 3 will be 2 root 3 square. Then root 2 times 3 root 2 will be minus 3 root 2 square. Then root 2 times 2 root 3, that will be minus 2 root 6 for the top. Over, now the denominator, 3 root 2 times 3 root 2 will be 9 root 2 square. Then 3 root 2 times 2 root 3, that will be 6 root 6. Then 2 root 3 minus 2 root 3 times 3 root 2 will be minus 6 root 6. Then minus 2 root 3 times 2 root 3 will be minus 4 root 3 square. So minus 4 root 3 square. So now we can simplify and solve. So what are we having? We have 3 root 6. 3 and root 2 square is 2. 2 times 3, that is 6. Then we have 2 root 3 square here. So root 3 square is 3 times 2 will be 6. Minus 2 root 6 over the denominator. This root 3 square is 3. See, root 6 minus root 6 will be 0. Then this root 2 square is also 3. It's also 2. Root 2 square is 2. Minus. Then this, we have 3 root 6. Then root 3 square is 3 times 2 will be 6. Root 2 square is 2 times 3 will be 6, so minus 6. Then we have minus 2 root 6 for that place. All over root 2 square is 2 times 9. That will be 18. Then 6 root 6 minus 6 root 6 will be 0. Root 3 square is 3 times 4. That will be 12. So now let's simplify and see what we get. So we have 3 root 6. 6 minus 6 is 0. So minus 2 root 6 over 3 minus 2, 1. Minus 3 root 6. 3 root 6. 6 minus 6, 0. So minus 2 root 6. Then 18 minus 12 is 6. So what we have? 3 root 6 minus 2 root 6 is just root 6. Divided by 1 is still root 6. Minus 3 root 6 minus 2 root 6. That will be root 6 over 6. So you realize that the result of this gives us root 6. And this gives us root 6. So you realize that the result of this gives us root 6, and the result of that gives us root 6 over 6. So what do? We need to simplify this by finding the denominator. The denominator is this is 1. The LCM will be 6. So all over 6. 1 will go into 6 times root 6 will be 6 root 6. Then minus 6 will divide 6 once times root 6, that will be root 6. So 6 root 6 minus root 6 will give us 5 root 6 all over 6. So we can say that this delta this is equal to 5 root 6 over 6. So now let's see the second aspect. They say hence we should deduce the value of root 3 minus root 2 operation 3 root 2 minus 2 root 3. Remember, when we solve this 3 root 2 minus 2 root 3 operation root 3 minus root 2, we have root 6 minus root 6 over 6. When we simplify to get 5 root 6 over 6, if you recollect very well. So now, let's deduce the value of that. So we can say that root 3 minus root 2 nabla 3 root 2 minus 2 root 3 will be that. Any place we see A in the operation, we substitute root 3 minus root 2. Any place we see B, we substitute 3 root 2 minus 2 root 3. So this will be root 3 minus root 2 all over 3 root 2 minus 2 root 3 minus this time around 3 root 2 minus 2 root 3 all over root 3 minus root 2. Now remember, when this was first and this is second, we had root 6 over 6. So since we change their position, it means this will be root 6 over 6 and this will give us root 6. That's what is meant by deducing it. So we'll have rather root 6 over 6 for this minus root 6. So the denominator there is 1. The LCM is 6. 6 will go into 6 once times root 6 will be root 6. 1 will divide 6. 6 times root 6 will be 6 root 6. Then root 6 minus 6 root 6 will give us negative 5 root 6 all over 6. So that becomes the value of this. So our next thing we'll be doing is an identity element. Now when we say an identity element under a binary operation, what are we referring to? The identity element is any element such that when it is combined with any element under the operation, then it will give that element. So this literature can be deduced into mathematical explanation. So if, let's say, E is the identity element, and let's say under the operation star, then we can say that when it is combined with any element, let's say A, that's A star E, the result will be A. So if it is combined with B, then we can say B star E is equal to B. That's why we said the identity element is any element, so that when it is combined with any other element under the operation, it will give that element. So if E is the identity element and it is combined with A, it will give the A. If E is the identity element combined with B under the operation, it will give the B. Now we'll take some sample questions and see how we can find the identity element defined on a specific operation. So now let's solve our first problem under the identity, finding the identity element of an operation. So they say the binary operation delta is defined on a set R of real numbers as m delta n equal to m plus n plus 10. You should find the identity element under delta. So how do we do that? So we say we should let E be the identity element. So remember the definition of identity element. We say if it is combined with any element, it will give that element. So we can say that m delta E will be equal to what? Will be equal to, so first m delta n is m plus n plus 10. And we say if E is the identity element, the m delta E will give us m. So how do we solve that? So when we want to find m delta E, any place we see n, now we substitute the E. So m delta E will be m plus E plus 10, and it will be equal to m. Now we can send the m there. So we have E plus 10 equal to m minus m. E plus 10 equal to m minus m is 0. So our E will be equal to 0 minus 10, and E is equal to negative 10. So the negative 10 is the identity element under this operation. So let's solve our second question. Our second question says that a binary operation star is defined on a set R of real numbers by A star B equal to A plus B plus 2AB. So find the identity element under the operation star. So how do we solve this? So we know that A star B is equal to A plus B plus 2AB. So we should let E be the identity element. And remember the operation of the definition of identity element. We say if E is the identity element, when it is combined with any of these elements, it will give that element. So we can say A star E will give us E. So in any place we see B, we substitute the E. So we can say A plus E plus 2AE will be equal to A. Now we have E plus 2AE is equal to A minus A. We send the A there. So we have E plus 2AE is equal to 0. What's common here? E is common. We can bring it out. So E out. 1 plus 2A is equal to 0. So E is equal to 0 over 1 plus 2A, which is equal to 0. So you can see that the identity element, under star, the operation star, is 0. So let's solve our last question under the identity element. They say binary operation nabla is defined on a set of real numbers as m nabla n equal to n plus n minus half mn. we should evaluate 2 nabla negative 3. Then find the true set of negative 2 nabla s equal to 4. Then we should find the identity element under nabla. So how do we solve that? So we'll solve our first one. Remember, m operation n is equal to m plus n minus half mn. So if we are asked to evaluate 2 nabla negative 3, it means any place we see 2, m we substitute 2 and n we substitute negative 3. So this will be 2 plus negative 3 minus half times 2 times negative 3. What are we having? 2 plus negative 3, that will be negative 1. Then minus 2 times half times 2, that will be 1. So 1 times negative 3. So have negative 1, negative minus 1 times negative 3, that will be plus 3. So this will give us 2. So we can say that 2, the operation negative 3 is equal to 2 under the operation. So now let's look at the second aspect. They say we should find the true set of the operation negative 2 nabla x equal to 4. So they are just simply asking us to find x. After we find x, we find the true set. So remember that m operation, the n is equal to m plus n minus half mn. So we can say negative 2 operation s will be equal to negative. So any place we see m, we substitute negative 2. Any place we see n, we substitute x. So we have negative 2 plus x minus half times negative 2 times x, and that will be equal to 4. So what are we having? Negative 2 plus x, negative half times 2, that will be 1, times x will be x, so plus x equal to 4. So we can say that negative 2 plus 2x is equal to 4. 2x will equal to 4 plus 2. 2x is equal to 6. And when we divide both sides, x will be equal to 3. Then we can say that s is such that s is equal to 3 for the true set. Now the next question is we should find the identity element. Remember, we said m nabla n is equal to m plus n minus half mn. So we should let E be the identity element. Then we can say that m nabla E, the identity element, will give us m. So any place we see n, we substitute the e. So we can say m plus e minus half me is equal to m. Now we can send the m there. So we have e minus half me equal to m minus m. So e minus half me is equal to 0. So we can multiply through by 2. We have 2e minus me equal to 0. What's common? E is common, we bring it out. We have 2 minus m is equal to 0. So e will be equal to 0 over 2 minus m, and e is equal to 0. So we can say that the identity element is 0. Please remember I said that the identity element is such that when it is combined with any element, it gives that element. Now, what is an inverse element? The inverse element is such that when it is combined with the element, it gives the identity element. So the inverse of A is written as is written as this. That's A exponent negative 1. So we say that the inverse element inside that when it is combined with the element, it gives the identity element. So we say in a mathematical term, A maybe operation, the inverse of A will give you the identity element. So that's how we solve this. So now we take some problems and see how we can find the inverse of an element. So let's solve our first question under the inverse element. They say a binary operation star is defined. A binary operation star is defined on a set of real numbers as A star B equal to A plus B plus 2AB. We should find A, the identity element under the operation, then B, the inverse element under the operation. Remember they say A star B equal to A plus B plus 2AB. And we say that we should let E be the identity element. So remember, if E, the identity element, is combined with any element, let's say A, then A star E will give us E. So A star E, that means in the place of B, we just substitute E. So we have A plus E plus 2AE equal to E. You can send the A there. So E plus 2AE equal to A minus E. E plus 2AE equal to 0. What's common? E is common, we bring it out. 1 plus 2A equal to 0. So E is equal to 0 over 1 plus 2A, and that's equal to 0. So you can say the identity element E is equal to 0. Now since we know the identity element, we can find the inverse element. Remember, we said the inverse, so we should let A exponent negative 1 be the inverse of A. So we can say that A star A inverse. Remember, we said the inverse element is such that when it is combined with the element, it will give the identity element. So we can say A star A inverse is equal to A. So A star A inverse, remember, in place of B in the operation, we just substitute A inverse. So I have A plus A inverse plus 2A inverse will be equal to the identity element. And the identity element is 0. So we say it's equal to 0. Then we can say A inverse plus 2A inverse is equal to 0 minus E. So we can say A inverse plus 2A inverse is equal to negative A. What's common here? A inverse is common. We'll bring it out. We'll have 1 plus 2A is equal to negative A. So the inverse of A will just be negative A over 1 plus 2A, where A is never and ever going to be negative half. This implies that when A is equal to negative half, it will make this undefined. So the inverse of A is negative A over 1 plus 2A. So solve the next question. It's a binary operation delta is defined on a set of real numbers as A delta B equal to 4AB. We should find the inverse under the operation delta. So remember, when we let A exponent negative 1 be the inverse of A, then we can say that A delta A inverse will give us the identity element. And how do we find the identity element? So we said the identity element inside that when it is combined with any element, it gives that element. So we can say A delta E will give us E. So A delta E simply means we substitute E in place of B there. So our A delta B E, A delta E will just be 4AE equal to E. So what do? We divide both sides by 4A to find E. So our E will be A over 4A. So A can divide this A. We'll have E to be 1/4. So the identity element under the operation delta is 1/4. However, our concentration is not on the identity element. We need the inverse element. So now that we find the inverse element, we said that when the inverse element is combined with that, the element whose inverse is that, it gives the identity element. So remember, A delta B is equal to 4AB. And we said that A delta A inverse will give us the identity element. A delta A inverse, it means that we just substitute A inverse in place of B. So we have 4A inverse, and it will give us the identity element 4, 1/4. So what do? We multiply through by 4 to remove this fraction. So we can say 4 times 4A inverse will equal to 1/4 times 4. So this will give us 16A inverse, and it will be equal to 1. 4 divided 4. Now we divide both sides by 16A. Here by 16A, our A inverse will just be 1/16A, where A is not equal to 0. When A is equal to 0, it will make this undefined. So the inverse element under the operation is 1/16A. So solve our last question under this. Please, before we do that, remember to subscribe to my YouTube channel if you are yet to. So the last question is a binary operation delta is defined on a set of real numbers by m delta n equal to m plus n plus 10. We should find the identity element. Then the inverse of 2 and -5. So how do we solve that? So remember, m delta n is equal to m plus n plus 10. So let E be the identity element. So remember, when it's the identity element and it's combined with m, it will give m. So in place of n, we substitute the e. We have m plus e plus 10 equal to m. So our e plus 10 will be equal to m minus m. E plus 10 equal to 0. E will be equal to -10. Then we can say the identity element is -10. Now we are asked to find the inverse of 2 and -5. So what do? We let m exponent -1 be the inverse of m. Be the inverse of m. Then we can say that m delta m inverse will give the identity element. So in place of n, we substitute the m inverse. We can say m plus m inverse plus 10 will be equal to the identity element. And the identity element is -10. So will be equal to -10. So we can say that m plus m inverse equal to -10 minus 10. M plus m inverse will be equal to -20. So m inverse will equal to -20 minus m. So the inverse of any element will be -20 minus that element. Then we can say the inverse of 2 will be equal to -20 minus 2, and that will give us -22. And the inverse of -5, the inverse of -5 will be -20 minus -5, and that will be -20 plus 5, and that will be -15. I hope you get it. We'll end it here today. Please check out my videos on how to prove that an operation is commutative, associative, and distributive. It has been a very good engagement. I wish you all the best.